let's talk about solving for an angle using a trig function. So if I look at this example, I see that I have this reference angle marked as x. Now, in relationship to that reference angle, I have this side that is opposite and this side that is the hypotenuse. So if I think about, DOA, I know opposite and hypotenuse means sine. So I'll have sine of my reference angle in this case is x equals my opposite side, which is 12, over 38. And then we need to solve for x. Now, how are we going to do that? Initially, you might think, oh, we need to divide by sine, but sine isn't a number, sine's a function. Now, if you remember when I was dealing with something like this, if I said, hey, I have x squared equals 25, I couldn't divide by that 2. No, that 2 is a square, so I needed to use the inverse. And the inverse of a square is square root. So I take the square root of each side, and x is going to give me 5. Well, what's the inverse of sine? Well, it turns out your calculator knows even if you don't. So we're going to actually ask our calculator. You'll notice right above sine, cosine, and tangent on your calculator are sine to the -1, cosine to the -1, and tangent to the -1. So we're actually going to use those inverse trig functions in order to solve. We have sine, inverse of sine. And we're also going to do that same thing to the other side. These two will cancel, and x is going to be equal to whatever the inverse trig function of sine is when we have 12 over 38 as our ratio. What will that give us? (18.4). So we know that x is an 18.4 degree angle. Let's look at another one. Looking at this one, I see I still have the same idea. I've got a reference angle. I don't know what the reference angle is. In this case, I still have my hypotenuse. But now this 3 over here, this side is actually coming in contact with the angle. So I know that this is my adjacent side. So which trig function am I going to end up using? Let's see. So, TOA, I'm going to use cosine. So let's set up our ratio. Cosine of x is equal to adjacent over hypotenuse, which is 3 over 6.5. In order to solve this, we need to use the inverse trig function, but this time it's going to be inverse cosine. You'll notice that I'm saying inverse cosine. I'm not saying cosine -1 or negative cosine. It's inverse cosine. Let's let our calculator figure that out for us. (62.5), and the 1 will make it stay the same. So x must be a 62.5 degree angle. Sounds about right. Let's do this one. Now, as I'm looking at it, I still have my reference angle x. I don't know anything about my hypotenuse. I do know this side is adjacent. And I know this side is opposite because it's the leg that's across from x. So which trig function am I going to use? Well, the only one that asks for just the opposite and adjacent is tangent. So I know tangent of x is going to equal opposite 9 over adjacent 4. Now, just like all the other trig functions, tangent has an inverse trig function. So we'll take inverse trig function or inverse tangent of both sides. And we know that x is going to be equal to the inverse tangent, negative 9 over 4. Again, our calculator knows what that is. Turns out it's 66.03. Or I guess the 3 would make the 0 stay the same, so we say 66.0 degrees. This is how we're using our trig functions to solve for angles. Okay, let's do some applications. It says a 21-foot ladder leans against a house with the base of the ladder 7 feet away from the house. Which trigonometric equation can be used to find the angle the ladder makes with the house? Okay, so I'm going to draw the house here. This kind of looks like the Wunzler's house from the Lorax. And we've got a 21-foot ladder. It's a long ladder. Leaning 7 feet away from the house. So that's 7 feet. Just going to highlight, this is the triangle that I care about. And we're trying to find the angle the ladder makes with the house. So I'm trying to find x. If I had been looking for the angle the ladder makes with the ground, I would have highlighted a different angle. So in relationship to this x, for where the ladder touches the house, this is the opposite side, and this is the hypotenuse. So which trigonometric function deals with the opposite and the hypotenuse? That's sine. So I know it's one of these two. Now sine is equal to opposite over hypotenuse. Opposite in this case is 7. So here's my answer. Now if I wanted to solve, I know I'm just going to be taking the inverse trig function of each side. So x is going to be equal to inverse sine of 7 over 21. That's going to be equal to 19.5, because the 4 would have been rounded up by the 7. All right, let's look at this problem. It says a company is installing a video surveillance system for a parking lot at a local aquarium. The camera is to be mounted at the top of a 40-foot pole. Okay, so let me draw that. Here's my 40-foot pole. Maybe it's got like a light on it. To the nearest tenth of a degree, find the angle with the pole that the camera needs to be installed at to aim at a spot on the ground that is 49 feet from the base of the pole. So we know we're measuring from the base of the pole, so that's 49 feet, and the camera's got to point at that. Okay, we care about, how does it say it? The angle, to the nearest degree, find the angle with the pole that the camera needs to be installed. So the camera is on the pole, and it's making an angle with the pole, so we're caring about this angle. Now, in relationship to x, this would be an adjacent side. This would be an opposite side, and we don't know anything about our hypotenuse. Adjacent and opposite are parts of tangent. So tangent of x is going to be equal to opposite, which is 49, over adjacent, which is 40. Now, I know in order to solve this, I need to use inverse tangent. These guys get to cancel, and we'll have x equal to inverse tangent of 49 over 40. That's going to give me 50.77. It says rounded to the nearest tenth, so the 7 will make the 7 round up, and x will be equal to 50.8 degrees. All right, one last example. It says a 13-foot ramp is propped against the back of a truck. So let's draw our truck. With a ramp coming off of it. It says a 13-foot ramp. If the distance from the end of the ramp to the back of the truck is 12 feet, so this is 12 feet, which trigonometric equation can be used to find the angle the ramp makes with the ground? So that's x. So if we're looking at this triangle, we have that as our reference angle, which would make this the adjacent side and would make this the hypotenuse. Which trigonometric function uses the adjacent and hypotenuse? So, okay, adjacent and hypotenuse, that's cosine. So we know cosine of x is equal to adjacent over hypotenuse. If I wanted to solve for x, I'm going to round my answer to the nearest tenth. I'm going to use the inverse trig function of cosine. These guys will cancel, and we'll get x equals cosine to negative 1 of 12 over 13. And calculator, what is that? Oh, you see I've made a mistake here. I typed in cosine of 12 over 13, but what I needed to do was inverse cosine of 12 over 13. If you get a number that looks very small like this, saying that it's less than 1 degree, you can assume that it might be wrong. There we go, 22.6. Again, make sure you're using the inverse trig function, so that's got the little negative 1, not the trig function when you're solving for an angle. Otherwise, it won't supply you with the correct answer.